Okay, so in this one, looks like the method that we're going to choose is going to be substitution, right? We know what y is equal to. It's equal to the square root of 6x plus 5. In the second equation, we have y, so we'll just make the substitution in there for y. So if we rewrite the second line, if we plug in our new y, which is the square root of 6x plus 5, right, that quantity is getting squared, and it's equal to 9. Then hopefully we recognize that square root and square, those two things will cancel each other out. So we get 3x squared minus 2x plus 6x plus 5 equals 9. And now we have a quadratic that's left, so we want to collect like terms and make it equal to 0. So that should give me 3x squared plus 4x minus 4 equals 0. And I believe that this factors, you can obviously, if you try to factor it, you can pause the video, into 3x minus 2 and x plus 2. Just check this real fast. That's a 6x. Yeah, that looks like it works. And then we set each of these pieces equal to 0. So we have 3x minus 2 equals 0, and x plus 2 equals 0 from the zero product property. So in one case, x is 2/3, and the other case, x is -2. If you check this, if you plug in the -2, it's not going to work in our original equation to find out a value for y. So x equals -2 is an extraneous solution. It does not exist. It was created when we squared this term. So let's check the second one. If we plug 2/3 in, then we get y equals the square root of 6 times 2/3 plus 5. That's 12 divided by 3 is 4. And the square root of 4 plus 5 is the square root of 9, which means that y is equal to 3. So we have one coordinate of 2/3 comma 3, and the other coordinate would be a -2, right? And if we plug that -2 in, it would give us the square root of -1, which does not work. So -2 does not work as an input.